We're going to look at exercise 6.3, which is using trigonometry to find unknown angles. Okay, so we're no longer interested in necessarily finding the unknown side, we're trying to find unknown angles. So to find unknown angles, you need to know how to find the inverse sine, cos, and tan, which undoes the sine, cos, and tan of an angle, leaving the angle by itself. Okay, so that makes sense because we want to undo the sine, cosing, and tanning of an angle, so we can get the angle by itself. We can solve for the angle and make it the subject. So on the CAS, the inverse trig buttons can be found on the trig menu on keyboard. Okay, so if you go trig, the inverse buttons are found here. Can you see sine -1, cos -1, tan -1? These are known as the inverse sine, inverse cos, and inverse tan, respectively. Okay, so let's just say I want to solve the equation. So looking at this, we 180 degrees min seconds. Cos of alpha, cos of A, equals 0.1538. Now, because the unknown angle has been caused, we want to undo the cos. Okay, so to undo it, you take the inverse cos. So inverse cos of both sides, inverse cos of both sides. If I take the inverse cos of that, the cos part goes away. So it's no longer cos of, it's just the angle itself. But what I do to one side, I need to do to the other. So I need to take the inverse cos of whatever I have on the other side. Okay, so this becomes inverse cos as well. Okay, when you inverse cos this, the first part, the cos part goes away, so you get whatever you're trying to solve. So alpha would be inverse cos of 0.1538. Okay, so I'm going to go ahead and go inverse cos of 0.1538. Click enter. I get 81.152 degrees. Now, I'm not happy with this because I need to convert to DMS. So I go to DMS. I'm going to highlight this, drag and drop, because I don't want to retype that again. Click enter. I get 81 degrees, 9 minutes, and 10 seconds. So you round it to the nearest second. 81 degrees, 9 minutes, and 10 seconds. 81 degrees, 9 minutes, and 10 seconds. Okay. Similarly for part D, I'll just in a different color. I want to find the value of k when cos k equals 0.556. So cos of k equals 0.556. I can inverse cos both sides, so that gets rid of the cos here. We get k equals to what I do to one side, I need to do to the other, so I need to take the inverse cos of the other side. Okay, so k equals the inverse cos of 0.556. Let's find the inverse cos of 0.556. So inverse cos 0.556. Enter. Again, I want a DMS, so I want to convert this to DMS. Copy and paste. I get 56 degrees, 30 minutes, and 13 seconds. So 56 degrees. So k equals 56 degrees, 30 minutes, and 13 seconds. Okay. So you just got to get used to the idea of when you're solving the angles, you usually have to find the inverse of the other side to get rid of whatever the trigonometric ratio is, okay, or the sine, cos, and tan. So calculate the angle for each of the following triangles. Write your angles to the nearest degree. Okay, so the convention is you always label your sides. So relative to the reference angle, this is my opposite, this is my hypotenuse, and this is my adjacent. Again, SOHCAHTOA, I know that I have the opposite and the hypotenuse. Sine is the ratio I want. Sine of theta, we don't know what theta is, so we'll leave it like that. Sine of theta equals opposite, 5 divided by hypotenuse 12. Can you see we've got an equation? We're trying to solve this equation for theta. Okay, so first step, I want to isolate the theta. So I want to inverse sine of both sides. So inverse sine both sides. The inverse sine of sine theta is just theta itself. The inverse sine of the other side is whatever that is. Okay, so theta, we're trying to solve for the angle theta. We go inverse sine 5 divided by 12, and correct to the nearest degree. Okay, so right here is correct to the nearest degree. We got 24.62, so the correct to the nearest degree is 25 degrees. Okay, 25 degrees. Part D. Relative to a reference angle, this is my opposite side, this is my hypotenuse side, and this is my adjacent side. So SOHCAHTOA, I have my opposite and my adjacent. So opposite adjacent is a tan ratio. So I can write equation based on this TOA. Tan of my angle, reference angle, equals opposite divided by adjacent. So 7 on 2. So to solve for theta, can you see we've got tan of theta. To get rid of the tan, you inverse tan both sides. So inverse tan both sides. So you should get theta equals inverse tan of 7 on 2. Okay. So theta would equal, work this out, inverse tan of 7 divided by 2, close brackets, 74 degrees. The nearest degree, 74 degrees. Okay. So these aren't too bad. You just need to know like how to solve this in a scenario. You just remember, you need to remember how to take the inverse or something. You can't use interactive event solve for this, unfortunately. You have to actually know what to enter to get theta. So you can still use a calculator, but you have to use it at the very end. You can't do it at this stage. So for question 3, this is my opposite side, this is my adjacent side, this is my hypotenuse side. I have the opposite and adjacent, so again it's TOA, so tan of my angle, reference angle, equals 3 over 14, theta equals, and we want it in degrees mid-second, so theta equals, I inverse tan both sides, so that gets rid of the tan here, but you introduced an inverse tan there. So theta equals inverse tan of 3 over 14. The inverse tan always has a negative 1. So you go inverse tan, 3 divided by 14, you get 12.09. Okay, so I want to convert to DMS. So let's do this quickly on DMS. To DMS, click that, enter that. 12 degrees, 5 seconds, 5 minutes and 41 seconds. 12 degrees, 5 minutes, 41 seconds. 12 minutes, 12 degrees, 12 degrees, 5 minutes, 5 minutes, and 41 seconds. Okay. Similarly for part D, this is my opposite side, this is my adjacent side, this is my hypotenuse side. You should be able to label it quite quickly. Okay. And we've got a tan scenario again. So TOA, because we've got opposite and adjacent. These are the two given sides. Tan of my reference angle is 0.6, which is opposite side, divided by adjacent side, 2.35. So theta equals, I take the inverse tan of both sides. Inverse tan of 0.61 divided by 2.35. So when I solve this, I go inverse tan 0.61 divided by 2.35. 0.61 divided by 2.35, 14.551. I want to convert that to DMS, so degrees mid-seconds. I click on this, drag and drop, close my brackets. 14 degrees, 33 minutes and 5 seconds. So 14 degrees, 33 minutes, and let's see what the seconds were. 5 seconds. 5 seconds. That's a double apostrophe. Okay. We'll quickly go over question 5. A sailing boat needs new sails. Only some of the measurements were recorded and given to the sailmaker, shown on the diagram. Calculate the values of the angles in degrees correct to 2 decimal places. So we're trying to calculate what alpha equals to and theta equals to. Okay, let's calculate what theta equals to. So if I redraw this part of the sail, theta is here. We know that's 2.5 height and 1.75. So that's opposite, that's adjacent relative to the reference angle. So we've got a tan scenario. So again, TOA. So tan of theta equals to opposite side 2.5 divided by the adjacent 1.75. I inverse tan both sides, so we get tan inverse 2.5 divided by 1.75. So the angle is, two decimal places, is inverse tan of 2.5 divided by 1.75, and I get 55.01. Okay, 55.01 meters. Not meters, degrees, sorry. Degrees. So we're trying to find an angle. So that's for part A. Part B, find the angle. Okay, I think I've done part B first. Okay, so this is part B. We'll do part A because we found theta. We're trying to find alpha this time. Okay, so part A was to find alpha. Let's draw it. Alpha's here. We've got 2.5. We've got 2.1. So relative to my reference angle, this is my hypotenuse side, and this is my adjacent side. So the trig ratio we want to use is Ka, so K-A-H. Cos of my reference angle equals adjacent 2.1 divided by hypotenuse 2.5. So to calculate alpha, I take the inverse cos of both sides because I want to isolate the alpha. You need to take the inverse cos of the other side, 2.1 divided by 2.5. Alpha equals, let's work this out, inverse cos of 2.1 divided by 2.5. 2.1 divided by 2.5. 32.86 degrees. Okay, 32.86 degrees. Okay. So hopefully you got a gist of how to calculate the angles, how to form an equation, and how to take the inverse of a ratio to get, the angle by itself. Hopefully